Without further ado, I do want to introduce Todd Halvorson from Florida Today. He's the Kennedy Space Center Bureau Chief for Florida Today, and a stalwart in the community for more than 25 years. Covered the space program through both the Challenger explosion and the Columbia loss upon return, and been involved. He's a winner of the American Institute of Physics Science Writing Award, the Science Journalism Award from the American Association for Advancement of Science, and has been generally one of the leading reporters in aerospace and technology reporting in the country. So we're very lucky to have you here, very lucky to have you in Florida, and very much appreciate his role, and I think we have a great panel today to talk about the turbine industry. So thank you.
Great. Okay, before I start, when you guys are ready, you'll need to come up here to the mic because we're having a little bit of difficulty with these guys right here. I'm Todd Halvorson, and they kind of call me the senior aerospace reporter at Florida Today and USA Today because I'm the oldest one and I've been around longer than anybody else probably doing this. And you know, one of the things that I specialize in is covering mission operations, and in space, clean, reliable energy equates essentially to life. Right now, the International Space Station has 6 people on board, 3 Russian cosmonauts, 2 American astronauts, an Italian astronaut representing the European Space Agency. Right now, they're traveling at 17,500 miles an hour. They're in an orbit that's about 250 miles above Earth. They loop around Earth. They circumnavigate the planet once every 90 minutes. They see 16 sunrises and 16 sunsets every day. And they do hundreds of research experiments, and they cannot survive without clean, reliable energy. The electrical system on the International Space Station is amazing. It's one of the greatest civil engineering accomplishments of all time. 8 photovoltaic arrays stretch 240 feet from tip to tip. That's a wingspan that is greater than the 747 that Boeing makes. Those arrays cover an acre of area in space. They generate 110 kilowatts of energy. That is enough power to light up a neighborhood with 55 homes. But if the power goes out on them, that's a bad day. That's a really bad day. Power in space is light. Down here on Earth, in the state where all the U.S. elements of the International Space Station were launched, reliable, affordable, clean energy is a powerful engine for Florida's economy. It's a major industry, it's a job generator, and that is important in the post-shuttle era when we have lost so many jobs here on Florida's Space Coast. The intent of a lot of people who have been here today is to use the skilled labor that we have here on the Space Coast. The skill set is very similar to what you need in the energy industry. And so companies that are interested in coming to the Space Coast can take advantage of that skilled workforce. And today we are focusing pretty much on Florida's energy future. And we have an expert panel here to give us kind of a look into the crystal ball, if you will, for the future of Florida energy. To my left here is Bob Shannon. He is an innovation management guy with Siemens Energy, and he's going to be talking about advanced gas turbines and offshore wind and ocean energy. And then to his left is Justin Sobol. He is a program manager for development with Florida Power and Light. and he's going to outline for us some of the current and future initiatives that Florida Power and Light is going to be doing here, as well as he's going to talk about their upgrades to existing plants and what their plans are for developing new generation infrastructure. And then next to Justin is Shirley Brostmeyer. She is the CEO of Florida Turbine Technologies. Shirley is going to talk about the potential of the energy industry to have a greater impact on energy efficiency in our existing power generation infrastructure. And last but not least, on the far left is Millie Herrera. She is a special representative of the Southeast region of the U.S. Department of Labor. And Shirley, our Millie has an interesting story to tell you about their efforts at the Department of Labor to attract more women into opportunities in our nation's energy industry, more minorities, to get a more diverse point of view on what is the future of Florida's energy going to be, and how they can take part in the emerging clean technology sector. So without further ado, I'm going to ask Bob Shannon to come up. I think we may be passing out paper for questions. If you have questions for any of the folks, please feel free to fill them out, or we'll have a Q&A session at the end of this session. And here's Bob Shannon. Bob, thanks.
Thank you, Todd. And thanks to Mike and the people at the Consortium for giving Siemens the opportunity to be here today. And so I'll take a little bit of time to give you some sampling of what parts of the energy business that Siemens Energy is in. So I'll start just here. It's home for Siemens Energy in Orlando, Florida since 1981, so we've been here quite a while, 30-some years, and we intend to stay here. Of course, there's over 3,000 people at this campus in Orlando, just across the street from the University of Central Florida, and nearby the research park where some of the speakers today also do their work. And one of the recent pieces of news this winter was our announcement that we're opening a wind turbine training center near the airport that will that is in fact now hiring and will be populated by 50 new jobs, and will host up to 100 people per week to train them to provide services to the wind turbine business. So they'll be going out and doing the service in the field for wind turbines in the Americas. So this is our headquarters for all of Siemens Energy in North America, and so it actually has more employees than our home office does in Germany in one particular office. So I have a lot to cover. The three topics we're going to cover here are gas turbines, offshore wind, and ocean energy. Just to put it in perspective, Gilbert Sterling, I think from DOE, the keynote this morning talked about the relative prices and grid parity and that sort of thing. So these are three topics that are selected. Some have a lot more impact on the Florida energy future than others, but they're kind of in a rank order, a double rank order here. The gas turbines, of course, are very large scale, produce a lot of electricity. Wind turbines, offshore wind turbines produce a bit less, but are more expensive, kind of in the middle. Gas turbines are down on the low end of the cost per megawatt scale, per megawatt hour scale. And then at the top end of the scale in terms of cost, but the lower end in terms of how much power is generated is ocean energy. So there's kind of a whole range of things there, just to give you a sampling of what we do at Siemens Energy. So basically, we're in the power generation, electricity generation, and transmission business in Siemens Energy. Other parts of Siemens do other things like building efficiency and all kinds of other energy initiatives. And we're also in the oil and gas business, providing key equipment to the oil and gas industry. So let's start with gas turbines. Just going to hit the highlights here. The most favorable at this point in the marketplace, and in terms of many things, including efficiency, capital utilization, and emissions meeting emission standards are natural gas combined cycle power plants. So basically it's a large industrial gas turbine, just like it's on the end of or under the wing of an aircraft, only as big as this room, perhaps, with a generator hung on one end, and waste heat coming out the back end. So the gas turbine drives a generator, produces a couple hundred megawatts of electricity from a large one. And then the waste heat can be just put into the atmosphere and you get that 100 megawatts, 200 megawatts. Or you can utilize the waste heat through a steam generator or heat recovery steam generator and produce steam to drive a steam turbine that drives another generator. So you can use all of that energy. This just gives you kind of a history. Our E-Series engines are older technology. They're operating lower temperatures, so they're less efficient. They're smaller. In the combined cycle mode, you can get up to 52% efficiency. Compare that to other fossil power generation efficiencies. A coal plant on average is maybe 35% efficient. If you go all the way to the end of the technology of coal-fired power plants, you could get maybe with ultra supercritical steam turbines, maybe 47%. So already the old gas turbine technology beats it in terms of efficiency. As we go up through the F, higher temperatures, larger engines, through the G, all the way up to the 8000H class, you get up to 60+% efficiency. That means the number of BTUs or the number of calories or the number of amount of energy going in as fuel, 60% comes out as electricity. So it's a significant improvement in how we utilize natural gas. And of course, where natural gas is plentiful or a reasonable cost, that provides a good option. And one of the reasons we're highlighting this as well is that Florida Power and Light has led in the U.S. in terms of being the first to use this technology to repower the Cape Canaveral plant just up the road here. I believe it was coal before. They've repowered it with 3 units of H-class technology. I believe they're operating now. And we don't quote the efficiency and the output of that because it's still being measured, but we can assure you that we put a large amount of investment into that technology so that that can be a good, reliable source of clean energy for our customers and for their customers. So the heart of this technology is the large industrial gas turbine. So this is the kind of the technology and the innovation part of it. The gas turbine technology is designed so that you can get this kind of efficiency and at the same time have operational flexibility. It used to be you just ran the plant at full power and that's where the efficiency is the highest and the emissions are the lowest. But now, because of some of the things you heard about renewables being fed in or other kinds of distributed power or just the dynamics in the power industry and the marketplace today, our customers need to have flexibility in how they operate their power plants. Well, we want that power plant to be as flexible as possible and still efficient and still meet emission standards. So there's a lot of technological challenges there, and basically the technologies that go into that so that you can kind of weigh it against the technologies available here on the Space Coast are a pretty good match because it's aerodynamics, because the gases are flowing against aerodynamic blades. It's heat transfer, it's combustion technology, they're just like a burner at the back end of a rocket, and it's advanced materials technologies because in the combustion zone in the first row of vanes and blades, those are operating at or near the melting points of the highest temperature metals that we can put in there. So the technologies are very cutting edge, and we put a heavy amount of investment. The most amount of investment we put into energy is into this kind of technology, as does our competitors. So the end result then is we can have a power plant like this one. The predecessor to the one in Cape Canaveral, which is a 60 hertz machine, is a 50 hertz machine in Germany, which was our flagship machine. They're bigger because they operate a bit slower at 50 hertz, so we can make them bigger and not exceed loads and stresses and things like that. And that one operates at 578 megawatts as a combined cycle power plant. So you put a couple of those together and that's the size of the biggest coal plant or the biggest nuclear plant around. And we can build and install them in a lot less time and a lot smaller footprint. The efficiency measured at that particular plant is 60.75, measured independently by others with very low NOx, NOx emissions less than 25 ppm, CO emissions less than 10 ppm. And for those who have a sensitivity to the effects of fossil power on greenhouse gases, CO2 of course is the concern. And natural gas, because it's burning, or a natural gas turbine is burning basically methane, so there's hydrogen in there, so there's about 50% less CO2 produced for the same number of megawatt hours as compared with a coal plant. So automatically you're reducing greenhouse gas emissions by 50% by switching to gas. So there's an advantage there as well. So we'll switch over real quick to wind turbines. We're a major manufacturer of wind turbines. We're a leading manufacturer of wind turbines that are in place and utilized for offshore installations. Most of the offshore installations that are very, very large right now are in northern Germany, Denmark, the UK, Norway, off the coast of Sweden, and mostly in the North Sea. And there's moves to have similar capabilities for other places in the world. Of course, you've probably all driven past maybe some onshore wind turbines somewhere if you've been further out west. Not really the right wind conditions inland here in Florida for wind turbines, so you probably won't see any. But you can see that we have 3 different models. 3.6 is the number of megawatts. So it's a Siemens wind turbine 3.6, 107 meter diameter. Okay, and then it goes all the way up to our latest model is a 6 megawatt. So 100 of those give you 600 megawatts, about like that gas turbine. 154 meters. Now this is bigger than any airplane in terms of wingspan. So each blade on the 154 is quite long. The 6 megawatt 154 meter wind turbine is also unique in that it's the first commercial large scale direct drive wind turbine. So we've reduced the number of moving parts by about 50%, and it increases the efficiency because now instead of going through a world's gigantic gearbox, of which Siemens is one of the few manufacturers in the world, so we're kind of innovating ourselves out of one product into another. But that's okay, we'll sell the gearboxes to the competitors if they would like those. And that's the way business works anyway. So we have our competitors' light bulbs, they have our gearboxes. But it eliminates a lot of steel going up on the top of that tower. So it eliminates the loads, and it's a more direct way to produce energy. The disadvantages are you have less control over the speed of the generation, so you have to run in asynchronously, and there's a bit more electronics that go into it, and they're large permanent magnet motors, so you have to have access to and the ability to design with rare earth magnet technology. So that's a key part of this technology as well. So we have significant concerns over the access and the supply, global supply of rare earth magnet materials, rare earths, and looking for alternatives to rare earths for permanent magnets. So that's a technology area of innovation that's of very high interest to us. And we're happy to work and do work with various universities and national laboratories around the world on those kind of problems. It's not, oh, there we go. And finally, we also have one test turbine where we can go into deeper waters, and that same turbine could be on a floating platform instead of anchored on the seabed. So I'll move real quickly. Recently, we acquired a company named Marine Current Turbines. It's a British company in Bristol, UK. And they're unique in that they're the leading marine renewable energy company in terms of how much energy they produced and put on the grid. So this turbine has, I believe it's the 1.2 CGen 1.2 megawatts. It's a utility scale prototype. It's been running since 2008. And I think it's designed to run through 2018. So the prototype has a 10-year life, and its basic design then is based on this kind of on an elevator shaft twin prop turbine that's in one of the inlets up in Northern Ireland. It's the Strangford Lough in Northern Ireland. So it's really working on tidal current. So it goes one way on 6 hours later, it goes the other way because of the high current. So that's pretty much what I wanted to cover. I'm here the rest of the evening to answer any detailed questions or any, any kind of other technologies you might be interested to hear about from Siemens. And turn it over to you.
Thank you very much, Bob. That was interesting.
One thing that came to our attention, if anybody has a Dodge Magnum, they're out in the back and they're blocking somebody else, so I don't know. You have to say,
There we go. There's your picture at least. Thank you. My name is Justin Sobol. As introduced, I'm in the project development group at Florida Power and Light. My primary focus right now is actually on fossil generation. And I'm going to talk to you about 3 projects today. We're actually using Siemens technology at those locations. It's the combined cycle modernizations up here at the Cape Canaveral facility that was previously mentioned. We've also done the same thing, or we're working to do the same thing at the Riviera power plant down near West Palm, and then the Port Everglades power plant down in Fort Lauderdale near the port there and the airport there. So I did one of the things as we were going through, and I was looking at what Bob was displaying. You know, we've got the combined cycle technology and the combustion turbines that we're using. We also, our sister company deploys a lot of the wind turbines. It's all on land for us with our sister company. And my background's actually ocean engineering and ocean energy, so hopefully someday we're working with them again on another technology off the coast of Florida. So my primary focus will be on the modernizations, but as we're up here and as discussed, you know, we are here talking about infrastructure and investing in infrastructure. In the state of Florida is our focus here with FPL. We've got a number of different areas that we're spending a lot of money in. We're talking about billions of dollars. Each one of these high-level bullets up here is in the billions of dollars in infrastructure that's being invested in the state of Florida. And it's been invested over the last couple years, even in the time when, you know, the economy was slower and things were a little slower here in terms of growth and generation and jobs. We were investing here in the state of Florida to harden the infrastructure for transmission, to better survive hurricanes and other events. We were also doing smart grid. I think many of you are probably FPL customers, and a number of you have probably received smart meters unless you've declined them. I think we've deployed it across our entire service territory. So each of the houses within our service territory have that, and that's a great benefit. We're learning about all the benefits of those smart meters every day as we continue to deploy them and learn about their capabilities. The other piece, then we start talking about the infrastructure, combined cycle, power generation, and Todd brought it up earlier. It's about cheap, clean, reliable electrical generation, and that's really our entire economy. And we're in here with electricity. Electricity is the basis for our economy, and we're doing a couple things to help reduce the cost of electricity, ensure additional reliability, and for improving the cleanliness of the electricity that we do produce. And so the other 3 main topics on here, we've got the modernizations, which I'll spend a little bit more time talking about since I focused on those projects. We've got the nuclear upgrades were just completed, and that was actually taking the existing nuclear power plants, upgrading a number of the components. And so with the same amount of fuel that was used in the older facility is producing a large amount of new generation from those existing plants, utilizing the same fuel, same infrastructure. And the last one, we've got natural gas pipeline. Majority of what's being done in the natural gas pipeline right now is focused on these individual plants and ensuring a reliable supply of natural gas, domestically produced, clean natural gas to those plants so they can operate almost continuously. We've got over 95% of the time these new modernizations are going to be operating because they are that efficient and the fuel is that cheap and clean. So getting a little bit deeper into the modernizations, we'll talk about the Cape Canaveral Energy Center, and that's the one right down the street here particularly. I'll focus on that today. But all of the modernizations kind of fit into this box, what we're seeing up here with the economic benefits. The Cape Canaveral project was actually initially, when we went to the Public Service Commission, we were looking at the project costing approximately $1.1 billion. Due to the economy, cost of materials, and a number of other things, it being a one-year demolition of the old plant, which was actually, it was oil-fired, primarily oil-fired, and to this new combined cycle natural gas facility, we are actually, we saved over $100 million from what we initially projected for the customers. And we're very excited about that. Hopefully we can do the same thing with the Port Everglades project and the Riviera project as well. The Riviera project was very similar to the Cape project, which was 800 megawatts of conventional steam through oil, primarily oil, replaced with approximately a 1,250 megawatt unit. And so I believe when you were showing the 600, I think that was a one-on-one combined cycle or a two-on-one?
Two-on-one, 50 hertz, which are bigger.
Okay, yeah, so 2-on-1, these are 3-on-1 combined cycles, and that's why we're up to the 1,250 megawatts of total generation. Port Everglades, the third project, and the one that we are, well, Riviera is a year away from COD or less, and the Port Everglades project, we're actually going through and doing the demolition of the old plant right now, and it was actually 1,200 megawatts. And the great thing about the Port Everglades project is we were taking 1,200 megawatts of generation, and we were putting back 1,250 megawatts of generation. And we are still saving, over and above the cost of construction, over the life of that plant, saving all of our customers approximately $450 million over the life of that project. And because of the fuel efficiency, the old plants to the new plants, between 33 and 35% more fuel efficient. And then they burn natural gas, which today is a lot cheaper than oil. And I'll talk about the environmental benefits on the next slide. Above that, we've got a number of jobs, and there are larger construction and infrastructure jobs out there in terms of job creation, but it's still a huge impact. We're looking at approximately 650 contractors out there working at the Cape Canaveral site. And if I remember correctly, the total number of folks on site on the one of the peak days was closer to the 900 or 1,000 people, and that includes FPL and a number of other folks that were out there.